Multi-response optimization of process parameters of WEDM using TOPSIS approach. Abstract. Present study deals with multi-response optimization of process parameters during wire EDM of EN31. In this study, process parameters like pulse on time, TON, pulse off time, TOFF, and peak current, IP, are taken into consideration. Taguchi method is used for designing the experiment. In order to optimize the multiple responses like machining time and surface roughness, technique for order preference by similarity to ideal solution, TOPSIS, method is used to get optimum parametric combination. Finally, conformity test is performed to check the validity of the proposed approach. Keywords: TOPSIS, optimization, Taguchi. 1. Introduction 2.2 Design of experiments. Wire electrical discharge machining is a non-traditional machining process which is based on material removal from a workpiece by means of series of repeated electrical discharge between electrode and the workpiece in the presence of dielectric fluid. A continuous traveling wire electrode which is controlled by the computer to follow a predefined path to cut a slot through the workpiece to produce the required shape. High-frequency alternating current is discharged from the wire to the workpiece with very small gap through an insulated dielectric fluid. The heat of each electrical spark erodes away the material. These particles are flushed away from the cut with a stream of dielectric fluid with the help of nozzle. This dielectric also prevents the heat buildup in the workpiece. In the past several years, researchers have used different methods to improve the machining characteristics during wire EDM of several materials. Amitesh Goswami at .al used Taguchi-based GRA method to investigate surface integrity (MRR) and wire wear ratio for WEDM of Niminic 80A. 1. Niraj Sharma et.al used response surface methodology to optimize process parameters for WEDM of HSLA steel. 2. JB Sedan at .al applied Taguchi-based GRA method to perform multi-objective response optimization for WEDM of titanium alloy. 3. Brajesh Kumar Lodhi at .al used Taguchi technique to optimize machining parameters in WEDM of AISID3 steel. 4. BJ Abhijit at.al proposed artificial neural network to investigate and optimize process parameters during WEDM of cryo-treated Inconel 718. 5. Niraj Sharma et.al used RSM with the help of genetic algorithm to optimize the process parameters during WEDM of HSLA steel. 6. Ashish Goyal used ANOVA to optimize the process parameters during WEDM of Inconel 625 using cryo-treated wire electrode. 7. JF Oberholzer at.al optimized the process parameters during WEDM of aluminium 7075 T6 using ANOVA. 8. Niraj Sharma et.al optimized the process parameters for cryogenic treated D2 tool steel by using RSM and genetic algorithm. 9. D. Sudhakarit.al applied Taguchi method to optimize the process parameters during WEDM of P/M cold worked tool steel. 10. Vikaset.al used Taguchi method to optimize process parameters during WEDM of EN19 and EN41. 11. V. Kavimani.al used Taguchi-based GRA method to optimize process parameters of magnesium composites. 12. G. Srinivasrao at.al used desirability approach to optimize process parameters during WEDM of ASS titanium alloy. 13. Sachin Sonawane.al used principal component analysis integrated Taguchi method to optimize process parameters during WEDM of Niminic 75 alloy. 14. G. Harinath Gaude.al used NSGA algorithm to optimize process parameters during WEDM of SS304 steel. 15. Samvar Singh Nainat.al used particle swarm optimization to optimize the parameters during WEDM of Udimit 605 alloy. 16. Rupesh Kalis Ankaret.al used utility concept methodology to optimize the parameters during WEDM of pure titanium. 17. R. Ramkrishnanes.al developed an model to optimize parameters of Inconel 718. 18. Biho Matthew et.al. Taguchi GRA method to optimize the parameters during WEDM of AISI 304 steel. 19. Bikashchud-Harriet.al used fuzzy logic methodology to optimize process parameters during WEDM of H21 tool steel. 20r.Sounderarajanet.al used RSM to optimize the parameters during WEDM of squeeze-casted A413 alloy. 21devierdiet.al used GRA method to optimize the parameters during WEDM of Ti50Ni48CO2 alloy. 22k.Deacarat.al used Taguchi method to optimize the parameters during WEDM of Marajing steel 350. 23 Sivaprasad.Arikotlayat.al used RSM to optimize the parameters during WEDM of titanium alloy. 24 v.Jangalreddy.et.al used GRA method to optimize the parameters during WEDM of aluminium He30. 25 Anshuman Kumar et.al used simulated annealing to optimize the parameters during WEDM of Inconel 718. 26. Past study reveals that WEDM involves large number of input parameters that affect the quality characteristics. It is worthwhile to investigate the relative importance between the input and output parameters. Due to the complexity and non-linearity involved in this process, good functional relationship with reasonable accuracy between performance characteristics and process parameters is difficult to obtain. To address this issue, the present study proposes technique for order preference by similarity to ideal solution, TOPSIS, model to determine the relationship between input parameters and performance characteristics. Most of the researchers have used Taguchi and GRA approach to optimize the process parameters. Multi-attribute decision-making techniques like TOPSIS, Promethe have not been used to find the optimal setting of the parameters for EN31. Thus, the analysis of improvement in the process using multi-attribute decision-making techniques is desirable. In the present work, an attempt has been made to find out the optimum parameters through multi-response optimization using TOPSIS to achieve minimum machining time, MT, and minimum surface roughness. 2 Experimental details and methodology. 2.1 Setup. Experiments were performed on Electronica Supercut 734. Alloy steel 300 of 200 mm 200 mm 7.5 mm size has been used as a workpiece material. Brass wire of 0.25 mm diameter is used as an electrode material. For present study, Taguchi parameter design approach is used for design of experiment. 6 process parameters are selected as control factors and other factors are kept constant. By referring orthogonal arrays table, L9 array is selected for the present study. Parametric combination for experimentation is tabulated as follows. 3 Multi-response optimization. In order to obtain the desired output with minimum usage of resources, it is important to follow the optimum combination of process parameters. The optimum parameter combination for one response may be unfavorable for other responses. Therefore, multi-objective optimization is necessary to obtain the optimum combination of parameters. 3.1 TOPSIS, technique for order of preference by similarity to ideal solution. TOPSIS helps to determine the most suitable alternative from the given sets. The technique used in TOPSIS is that the selected solution should be nearest from the positive best solution and farthest from the negative best solution. 3.1.1 STEP1. The normalized matrix is obtained by the following expression. The weight of each attribute was assumed to be Wj, j equals 1, 2, 3. The weighted normalized matrix can be obtained by U equals IJERT. Separation between alternatives from positive ideal solution is expressed as plus equals V, plus, equals 12, I equals 1, 2, 3, M. Separation between alternatives from negative ideal solution is expressed as dash equals V, equals 12, I equals 1, 2, 3, M. 3.1.5 STEP5. Relative closeness of the alternative to the positive ideal solution is given by pi equals dash plus plus I equals 1, 2, M. From the analysis it is clear that experiment number 7 is the best multiple performance characteristics having highest preference order followed by EXPT number 4 and EXPT no. 5. The optimum parametric combination can be determined by considering the higher values of preference order. For conclusion, in the present investigation, multi-response optimization technique is used to optimize the process parameters during WEDM of EN31. The optimum combination of parameters using TOPSIS approach are TON3 TOFF1 IP3, i.e. third level of TON, first level of TOFF, third level of IP, for experiment number 7. The machining time and surface roughness is 6.25 minutes and 3.3 micron respectively at optimum levels. It can be stated that TOPSIS approach can be useful to optimize multi-response characteristics for any manufacturing process.